The more efficient way to construct this proof is to not use subproofs, which is in the solution key for the quiz, but I just wanted to demonstrate how to do this proof using subproofs, and it's a good show, or rather, of some of the restrictions on our various rules. So if you're using subproofs, the most obvious assumption to make here is just the opposite of conclusion for an indirect proof strategy. Now, other things to notice before we do anything else is just what our premises are giving us. And importantly, what they're giving us is a bunch of, well, horseshoes and wedges and not generalizations. The most common mistake here is just to try to EI online or something like that. And of course, we can't do that because we don't actually have a generalization at line 1. We have a conditional whose antecedent is a generalization. Okay. Now, what we do have, though, are horseshoes and wedges, and so, what to look for in terms of building your strategy for this proof? Well, since line 1 is a horseshoe, then we're looking at maybe trying to use modus ponens, modus tollens, the other conditional rules, in other words. Right. And with line 3, because it's a wedge, we're looking to maybe be able to use DS or any of the other add rules, including, replacement rules for each of these as well. Implication, maybe. Or, as you saw in the direct way of doing this proof, tautology, so on and so forth. Next, all we have so far is that B is an H. Since the H predicate occurs only in line 2, then that narrows our something with 2 and 4, or at least most likely. We already had S and the other wedge rule options as a possibility here, and so if you're not seeing how the proof proceeds, the ultimate fallback, it's not a very efficient way of constructing proofs, but the ultimate fallback is always sort of trial and error. With line 2 here, right, if we were going to use DS, we would want something like this, for example. Of course, this is line 2, and whatever line this is, DS. Right, and so part of the question is whether or not that B is an H lets us derive that it's not true that everything is not an H. Now, when you say it in English, of course, this line does follow validly from line 4, right? Line 4 tells us that B is an H, and so of course it's not everything is not an H. How do we get there? Well, the next step is just mechanical. We've got tildes and quantifiers, and so that's an indication that CQ is somehow going to be involved. And if CQ is involved, then and looking at R, really, Existential generalization on line 4 is our only option. UG wouldn't be legal on line 4 anyway because line 4 contains a constant and not, again, given what we're hoping to be able to derive, or rather I should say knowing what does follow from line 4, we don't want the universal generalization yet anyway. We don't want the universal generalization anyway. What we want is the existential generalization, which we can then see to get the negation of our right-hand side to derive. Okay. What happens